Okay, this is an exercise from section 8.2, testing a claim about a proportion. This is question 4, or you can refer to it as 8.2.18-T. Now, in this exercise, a genetic experiment involving peas yielded one sample of offspring consisting of 448 green peas and 165 yellow peas. Use a 0.05 significance level to test the claim that under the same circumstances, 26% of offspring peas will be yellow. So identify the null hypothesis, the alternative hypothesis, the test statistic, the p-value, conclusion about the null hypothesis, and final conclusion that addresses the original claim. Use the p-value method and the normal distribution as an approximation to the binomial distribution. So before we answer these questions, I'm gonna kind of flip pages here, and we can look at this where we can do some scratch work. And so I'm going to set a pin up here. So a genetic experiment. So the first thing I want to do is kind of organize some of this information. The number of green peas here is equal to 448. So there's 448 green peas. And it looks like for the yellow peas, there are 165. So we should probably figure out the total number of peas at this point so we know what our sample size is. So I'm just going to quickly add 448 plus 165, and we see that our n, so the number of peas here in this sample, the total number of peas, n, is equal to 613. Now it says to use a 5% significance level to test the claim that under the same circumstances, 26% of offspring peas will be yellow. So the claim is that 26% of a similar sample will be yellow. And really, maybe, we'll leave that. We'll leave that there. That's not the best written sentence. I probably should have said 26%. 26% will be yellow peas if we were to take a similar sample. But hopefully, you're picking up what I'm putting down there. And we could make this claim into a symbolic form by saying that the proportion is equal to 26%, or we could write that as 0.26. So now we know that this is our claim, and notice that it has an equal sign in it. So that becomes our null hypothesis. So our null hypothesis is that the proportion is equal to 0.26, and the alternative hypothesis is that it's not equal. The proportion is not equal to 0.26. So that is pretty much, it would appear, all the math really we need to do. The rest of this we can do in StatCrunch. So we've identified the null hypothesis, we've identified the alternative hypothesis. The test statistic and the p-value we will get out of StatCrunch, and then the conclusion about the null hypothesis and the final conclusion, we'll make that once we have everything in StatCrunch. So the first thing I'm going to do is go over and plug this in so I get the correct answer there, and then we'll pull up how to get the p-value and everything. So we want, it looks like option B is the hypothesis, the null hypothesis, and the alternative hypothesis that we set up. And I'm going to back this out a little bit so it's not super gigantic like it was. We check our answer. It looks like we get that one right. Now, the next part is what is the test statistic. So here is where I'm going to open up StatCrunch. And I'm probably going to try to arrange my screens in such a way that we can see everything on one screen. And we want the StatCrunch screen. There we go. All right, so our test statistics. So I'm going to go into stat. I'm going to go into proportion stats. This is one sample, and we're going to do this with our summary information. Now, the total number of successes in this case were the yellow peas. That was our number of successes. So we had 165 successes out of our total observations. Well, remember the total observations, that's this n here that I wrote down. N equals 613. Remember, it's the total number of peas. So my number of successes here was 613. And now I'm going to set my hypothesis test up exactly like what we selected in option B. So the proportion of null is actually 0.26. I'm going to leave the default not equals for my alternative hypothesis. And that's it. That's all I'm going to do. I'm going to hit compute here. And now I can see what my test statistic is. So I'm just going to key that in here to MyLab Stats to 2 decimal places. That's going to be 0.52. So 0.52 there. Okay, apparently I don't know how to type into boxes. So 0.52. And we get that one correct. All right, now our p-value is in this box here. So this is our p-value. So to 4 decimal places, I'm just going to type that in exactly how it's written there. So 0.6048. Okay. 0.6048. And check our answer there, and we get that one right. All right, so now what is the conclusion about the null hypothesis? Well, we're using a significance level of 0.05. All right, so our p-value is certainly larger than that. This is 0.6048 compared to 0.05, so the p-value is definitely larger. So when our p-value is greater than our significance level, we fail to reject. And one way I remember that is when the p is high, the null will fly. So the null hypothesis is going to stay right where it is. So we fail to reject the null hypothesis because the p-value is greater than the significance level. So option B is what we're looking for there. If you look at D, fail to reject the null hypothesis because the p-value is less than, we'll know the p-value is in fact greater than our significance level. So that's why we're failing to reject. And we should get that one correct, and we do. And then finally, what is our final conclusion? So I like to refer to this table here. So started out, does the original claim contain the condition of equality? It did, right? Yes, the original claim was the equal sign. So do we reject our null hypothesis? No, we did not. We failed to reject. So what we're looking for is there is not sufficient evidence to warrant rejection of the claim that. So there is not significant evidence to warrant rejection of the claim that. So that's the one I'm looking for. So there is not sufficient evidence to support the claim. Nope. There is not sufficient evidence to warrant rejection of the claim that the 26% of offspring will be yellow. I really like option C. Let's see how we did there, and we get that one right as well. So that again is exercise 4 out of section 8.2. Testing a claim about a proportion. You can also refer to this exercise as 8.2.18-T.